This video intends to explain how to use probability and statistics to make educated decisions, and why sometimes higher probabilities doesn't mean is the best option. It's very important to look the context and see how it is being applied. So for example, let's say we are trying to resolve this logistics or this transportation problem, right? Let's assume that we want to compare who's the best carrier, right, for FedEx or DHL, right? Let's assume that we took their on-time delivery performance for the last 12 months. And we know that for FedEx, when they ship by train, it gets on time to us 80% of the time. When they ship by truck, it gets here on time 40% of the time. On DHL, it gets here 100% on time delivery when they ship by train, and 60% on time delivery when they ship by truck. So just by checking their on time delivery on the last 12 months, you can maybe think that DHL is the best option, right? It's 20% higher on time delivery than FedEx, and over here is also 20% higher in on time delivery than FedEx, right? However, you will see that if you don't check their shipping plan and how many quantities, or like how much, or the portion that they're shipping on each of these options, you won't really know who's the best supplier, right? Or who's the best carrier, I mean. So let's assume that their shipping plan for FedEx is that 80% of their stuff is shipped by train, and the remaining 20% is shipped by truck. Let's assume that for DHL, 20% of the total shipments goes by train, and 80% of their total shipments goes by truck. Right now, that being said, how can we check what is the probability of FedEx being on time, and how can we check the probability of DHL being on time, right? So this can be done by looking at probability as a big proportion, right? Taking portions or percentages over a total sample space, right? So let's say for FedEx, right? Let's assume that for FedEx, this is our entire sample space, right? We know that on FedEx, as you know, 80% goes by train, and the remaining 20% goes by truck, right? Out of the 80% that goes by train, 80% is on-time delivery, right? So let's say 80% of these. So all this area is on-time delivery, right? Similarly, for the truck, 20%, right? But just 40% of it gets on-time delivery by FedEx, right? So let's see, it's around here. So how do we calculate this? Simply by train rate. So 80%. Out of that 80%, 80% is on time. So times 80%. We're taking that portion of that. Plus 20%, right, of the total shipments, times, and they're on time 40% of the time of that 20%, right? And what is this? So 64 and 8, perfect. Yep, 72%. Okay, we apply a similar approach with this, right? With the on-time delivery for DHL. So for DHL, right, 20% of their shipments goes by train. And out of that 20%, 100% gets on time, so times 1. Similarly, by truck, 80% of the total shipments goes by truck. And out of that 80%, we're expecting 60% to be on time. So, and that should be around 68%. 20, 48, 48, yep, 68%. So here you will notice that FedEx is your best bet. FedEx is your best option, right? Even though at the beginning it seemed it was the worst option, right? Because their probability, their on-time delivery probability was showing that was much less. But everything depends on the shipping plan. So what I'm trying to get at here is like always utilize probability and statistics with some perspective, with some background information, making sure you're applying it correctly. That way you can make educated guesses about it.